So while some of you are finishing up your warm-up, you can kind of look up here to check your process. All right, do you have any questions on these? You okay? Okay. One thing, know that my pen on my air slate is like skipping for some reason, so things might look a little weird. Just give me a second and I'll get caught up with it. Now, these were kind of suited for substitution and for elimination, so make sure you're paying attention. If you tried to use substitution in B, you've created a lot of extra work for yourself, okay? And we want to keep our work minimalized as possible. So what we are stepping into today with our second day of systems is systems of 3 variables. 3 variables requires 3 equations, okay? And we are going to work how to solve these 3 variable systems by hand, okay? In a couple days, Thursday or so, you're going to be really mad at me because I'm going to show you the easy way to do this. But in order to appreciate the easy way, we have to struggle through the hard way first. Yes, we do. All right, so 3 variables means 3 equations in a system. So in this system, this one's actually set up nice for us. What do you notice is true? Yeah, they already gave us that x is 2. All right? So what do you think we're going to do with that information? Okay, we're going to plug it in for x in each of our other equations. This is going to give me 2 times 2 minus y plus 3z equals negative 2. And 5 times 2 plus y minus z equals 14. All right, I want to go ahead and simplify these combined like terms, okay? So I know 2 times 2 is 4. So I'm going to go ahead and subtract my 4 over here. So would you agree that I have negative y plus 3z equals negative 6? Okay, and I've got y minus z. This is 10, so if I subtract 10, I'm going to have 4. Would you agree that that's my new system? Okay. What is this system very well suited for? Elimination. I already have my negative y and my positive y all ready to go. I don't have to manipulate anything. All right. These cancel. 3z minus z. 2z equals negative 6 plus 4. Negative 2. So what is z? All right. So now I have x and I have z, and I need to find y. What am I going to do to find y? Yeah, I got to plug into a -1. It doesn't matter which of these two equations you use. I choose the one with the smallest numbers because, again, I want to make my life easy when possible. Yeah. I would recommend that when you are finding your final variable, you go back to the original equation, because had I accidentally messed up in plugging in my x value, I will be able to catch my mistake when I check it. Okay? So let's use this 2x minus y plus 3z equals -2. So 2 times 2 minus y plus 3 times -1 equals -2. So what do we get for y? Y equals 3. All right. I'm sorry? I'm sorry? Yeah, I did. 4 minus 3 is 1. Subtract 1 from -2. It's -3. All right, so to write your solution, you're going to go x, y, z. So 2, 3, -1. Or go in alphabetical order. Questions? Okay, let's check our work. It is so easy in any systems to mess up, but especially when you're solving for an extra variable. Okay? So always take your solution and go back and plug them into your original equations and check your work. Yes, you might have to do a little computation over to the side, but it's going to be worth it. Okay? Had I forgotten to put that negative there, or like I did in the homework where I made those little mistakes, it's so easy to make, right? So you've got to check yourself. So let's check. 2 times 2 is 4, minus 3 is 1, plus 3 times -1. So that's 1 minus 3. Does that give us -2? Yeah. Okay, 5 times 2 is 10. Plus 3 is 13 minus -1. Does that give us 14? Yeah. So we're good. Okay, let's look at number 2. Stepping it up just a little bit. This time they don't actually just give you a value, but they do give you a couple equations that have only 2 variables. And some of those variables don't have a lot of coefficients. So they have still helped us out a little bit. All right, so my method here is going to be to do kind of a glorified substitution. I'm going to use one of those 2 equations at the bottom where it's only 2 variables, and I'm going to solve for a variable, and then I'm going to plug into the other ones. Okay? Now, keep my life as easy as possible, right? So I want to make sure I can keep things positive when I can, use the smallest numbers that I can. So where I would see that happening is in this bottom equation. If I solve for z, what do I get? Y plus 3. That's nice and easy, right? No negatives, no big numbers. Okay? So I'm going to take that z equals y plus 3, and I'm going to substitute it into the 2 places I see z in the other equations. So I'm going to have x plus y plus 3. And I've got 2x plus y plus 3 equals 12. Can we combine like terms and simplify these equations? Yeah. So x, I'm going to come down here, x plus y is 2y. And then if I move this 3 to the other side, what am I going to have? 7. Then I have 2x plus y. Again, I'm going to move this 3 over, and what am I going to have? 9. Is this something we know how to solve now? Yeah, go for it. All right. To me, this looks like I should use elimination. So I'm going to get rid of my x's. So in order to do that, I'm going to multiply my top equation by negative 2. So this is negative 2x minus 4y equals negative 14. And my bottom equation would stay the same. Negative 4y plus y is negative 3y. What's negative 14 plus 9? Negative 5. So what is y? Positive 5/3. All right. What would be the next best variable to solve here? Yeah, I would go for z, because z is in terms of y. So z equals y plus 3. So z equals 5/3. How could I rewrite 3 to help me out here? 9/3. All right, so what is 5/3 plus 9/3? 14/3. So z is 14/3. All right. Now, what might be our easiest equation here to solve for x? Okay, I agree that the top one doesn't have coefficients, but notice how the middle one only has one other variable, right? So up there, we're going to have the 5/3 and the 14/3. Down here, you're only going to have the 14/3. But either one works. I'm just trying to show some hints into my thinking, but it's totally your call. So I've got 2x plus z equals 12. And I'm going to have 2x plus 14/3 equals 12. And I'm going to rewrite 12 as 36 over 3. When I subtract 14/3 from both sides, what am I going to get? Okay, so 2x equals 22/3. All right, and what am I going to do with this 2? Good, multiply by 1/2. So x equals 22/3 times 1/2. What happens with the 2 and the 22? Yeah, they can reduce to 11. So this is x is equal to 11/3. Okay, now, at home, I would double check this on your calculator, okay, on a test or a quiz. If you had time, I would double check it. In a perfect world, you're always going to double check, right? But if you're short on time, sometimes you got to move on, okay? Most times when you get weird numbers like this, it'll be on the calculator part. I'm not saying you're not going to have a fraction here and there on the non-calculator part, but most times it'll be pretty numbers, okay? All right, questions? All right, let's step it up a little bit. I know, we're stepping it up a little bit more each time. All right, 3 equations, 3 variables in each equation. I know, that's why I crossed my z's. The z's will be crossed. Okay, another method we can use to solve 3 variable systems is called double elimination. Okay? So for double elimination, the process that we're going to use is to eliminate one variable from equations 1 and 2, eliminate the same variable from equations 2 and 3, and then use those 2 equations that we get and solve. Okay? Like I said, this stuff isn't necessarily really hard, it's just tedious. All right, so what I'd like for you to do is number your equations 1, 2, and 3. And we're going to eliminate. Yeah, I agree. In this case, would you agree that Z is set up the best to be eliminated? It's got positives and negatives. We got nice small numbers, no fractions. So we're going to eliminate Z from 1 and 2, my first and my second equations, and 2 and 3. So let's start by rewriting equation 1 and 2. Okay, what are we going to need to do to this equation, these 2 equations, to eliminate Z? Okay? Just by looking at the 3 variables, to me Z looks like the easiest to eliminate. Because it's got small numbers, there's a positive and a negative and a positive. But there's no rule that says I had to pick that one. Okay? All right, let's do this. 9x plus 5y. These z's cancel. So 9x plus 5y equals 12. We all okay there? Okay, now let's go ahead and eliminate z from equations 2 and 3. Isn't it already what? Well, it's not done, but we do not have to manipulate our equations. We can just go ahead and start eliminating. So that's nice. We don't have to multiply by anything. 2x plus 1/2 x. 5/2 x. Y plus 2y is 3y equals 13. These? Yeah. These 2 equations come from the manipulations I did to my 1 and 2 in order to set up elimination. So I didn't change anything about the first equation, and I multiplied the second equation by 2 so that I could eliminate my 2z and my negative 2z. Everyone okay so far? Okay. Now, I have 2 new equations in blue. How many variables are in those 2 equations? 2. Okay? So I have two equations in blue. They both have two equations, so can we solve these? Yeah. So that's going to be what we focus on now. All right? Now that we've eliminated z, we're going to go ahead and solve our equations with just x and y. I said it's not that hard, it's just that it's tedious. Yep. Lots of possibility for mistakes. That's why we got to be slow and careful. Okay. 5 halves x plus 3y equals 13. 9x plus 5y equals 12. What do you want to use? Okay, what do you want to eliminate? All right. So let's go ahead and multiply the top equation by negative 5. And the bottom equation by 3. So I'm going to get negative 25 halves x minus 15y equals negative 65. And you get 27x plus 15y equals 36. Okay, my y's cancel. I'm going to rewrite 27 as 54 halves. So negative 25 halves plus 54 halves. What are we going to get? Positive or negative? Okay, so 29 halves x equals negative 65 plus 36. Negative 29. What am I going to multiply both sides by? Okay, I could break it into two steps, multiply by 2, divide by 29, or I can multiply both sides by 2 over 29. So I get x equals negative 2. All right, we got one. Yay! All right, let's find another variable now. You got to know the process. Because it's worth it. Because you got to understand what the calculator is doing. Because you do. Yes?
Now that we have x equals negative 2, can we plug that into our blue equations to get y?
That's exactly what we're going to do. Okay, so now we're going to plug in and solve for y. So to solve for y, we're going to use one of these blue equations. Okay, I would go ahead and lean towards the one without the fraction because I know how much we hate fractions in here. So we have 9x plus 5y equals 12. So 9 times negative 2 plus 5y equals 12. So negative 18 plus 5y equals 12. 5y equals 30. Y equals 6. Okay, so now that we have x and y, we're going to plug back into one of our very original equations. I agree, the middle one. And we're going to solve for z. So I'm going to use 2x plus y minus z equals 5. What's z? Good. Okay, I would go back and check this. Okay, so make sure on your homework tonight and on your quiz on Wednesday that you're checking your work. And then we write our solution as -2, 6, -3. Yeah, go back to the original equations and plug it in. Questions? Yep. Yep. Yep, I used one of my eliminated, where I eliminated z. Because all I have so far is x, so if I want to solve for another variable, I have to use an equation where there's only 2 variables. Does that make sense? Okay. Other questions? All right. The sum of 3 numbers is -4. The second number decreased by the third is equal to the first. The sum of the first and second is -5. Find the product of the 3 numbers. This is the last one. It will take up less space than the one before. It depends on, I don't know how you write. No, my notes are very long, the ones I did by hand. It's not like this just magically comes into my head. I sit down and do this all first, too. Yes. Okay. Shh. Let's stay focused, guys. Nope. Okay. So we've got to set up a system. How many variables are going to be in my system? 3. So how many equations do I need? 3. So I'm going to go ahead and let x be my first number, y be my second number, and z be my third number. Okay, ideas on our equations. Matthew. No, just give me one.
Okay. X plus y plus z equals -4.
Good. Other equations. Jason? Y minus z equals x. Yep. One more. Good. X plus y equals -5.
And with that, can't you plug -5 plus z equals -4?
Say that one more time.
So since you know what x plus y is, then for the very first equation, you just do -5 plus z equals -4.
Yep. Okay. What I'm going to choose to do here is use substitution. Okay? And what I notice is that this middle equation right here is already solved for x. Now, do you have to use this equation when substituting? No. You can pick something else. That's fine. Again, I'm trying to save myself work. That one's already solved for x. Okay? So wherever I see x, I'm going to plug in y minus z. Yes. You have to plug it into both equations. All right, so let's go ahead and combine like terms here. Y plus y is 2y. Negative z plus z is 0. So we have 2y equals -4, which makes my life very easy because I know I'm going to be able to get a variable real fast. Okay? What's wrong? Okay. Y plus y is 2y minus z equals -5. All right, so what do we know here? All right, that helps. How did I get what?
Oh, never mind. I have negative.
You sure? Okay. Okay, so now I'm going to plug in y right here as negative 2. So I have 2 times negative 2 minus z equals 5. So negative 4. Thank you. Negative 4 minus z equals negative 5. So negative z equals negative 1. Z equals 1. Okay? And then I'm going to take my y and my z and go back into one of my original equations and solve for x. Okay? I can either use this x, this middle one that's already solved for x, or I know this one only has 2 variables. At this point, it doesn't really matter. My numbers are pretty simple here. So it's kind of up to you. What do you want to use? The middle one? Okay, so x equals y minus z. So x equals negative 2 minus 1, so x equals negative 3. What's your question asking you for? All right, so we're going to find the product, which is negative 3 times negative 2 times 1, which is 6. Questions? Because the question asked you for the product. Okay? Now, guys, I know it's annoying, but the process is really important, all right? So be prepared. If you're someone that normally rushes through your homework at 8:30 in the morning before school starts, this isn't the night to do so. This is not a short homework assignment. You can tell from these problems this isn't going to be short. So make sure to give yourself enough time